Hey, calculus people. Hope you guys had a restful spring break. I just want to make sure that we ease into limits. I know that you guys have seen limits over and over and over again, but it's one of those topics that gets easy to forget. So I'm gonna come up with tips for limits. So again, the first idea is to always try direct substitution first. You never know. The problem might be as easy as just plug it in for x, because if the point itself is defined, that usually means that the left and the right hand limit want to go there. Okay, so the second part is if you have a 0 over 0 or some sort of infinity over infinity, that means that it's called an indeterminate form. In other words, okay, we don't know if it's a whole, we don't know if it's going to flatten out in the end. We don't know if it's going to go to infinity in the end or if it's going to go to 0 in the end. Either way, we don't know where the intent is by direct substitution. So you can either factor the numerator and the denominator and cancel out, or you can use L'Hopital's rule. I don't have a preference which one, but your college professor may prefer the factor and cancel out way. But I'm giving you L'Hopital's rule because it's like a safety net when you go to college and you do these problems. Like, okay, I can do it this way. At least I'm confident I understand the main idea. Number 3, if you plug in a value of x and you get a number over 0, so a non-zero over 0, well, that creates a vertical asymptote. So my biggest tip for that is to pay attention to the signs on the top and bottom. Specifically, the exponents might mess things up for you. So pay attention to whether you have a positive over the right side of 0, a positive over the left side of 0, a negative over the right side of 0, or a negative over the left side of 0. So those will tell you whether the left and the right hand limits want to go to some form of infinity, or whether one goes to positive infinity, one goes to negative infinity, in which case the limit doesn't exist. Okay? And finally, number 4, the main idea is if you get infinity on top and and some number on the bottom, that means that the infinity is going to win the race, so to speak. So if you have infinity on top over 1, that goes to infinity. However, if you have 1 over infinity, think 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 10, 1 over 100, 1 over a million. It's getting closer and closer and closer to 0. So there's a lot more tips for limits, and the more practice you get, the stronger you'll be at it. But those are the main 4 that come to mind for me if I could go back in time and talk to myself at age 18 and be like, okay, this is what you need for limits. It's all about intent, and you have a variety of tools to figure out the intent at the given x value. Okay, so let's talk about number 1. So always think critically about your problem. So I just gave a lollipop kind of problem. So if you have the limit as x approaches 4 for 9x minus 15, you'll look at it. We've had months and months of experience with this. Come on. There's nothing wrong with plugging in x equals 4 to the expression 9x minus 15. But we're going to change our mindset and say we're approaching x equals 4 from the left and the right side. And if direct substitution is okay, then it works. So let's plug in x equals 4. So what that means is we've got 9 times 4, which is 36, and 36 minus 15, that's not an indeterminate form, and 36 minus 15 is 21. Instead of algebra saying plug in x equals 4, the idea is as x gets closer and closer and closer to 4, y gets closer and closer and closer to 21. In fact, the point 4 comma 21 is it's defined. So x equals 4 is a continuous point. Okay? Whereas if you plug in over here the limit as x approaches 5, if I plug in 5 minus 5 over 5 squared minus 8 times 5 plus 15. So that would be 5 minus 5 is 0, and that'd be 25 minus 40 plus 15. 25 minus 40 is negative 15. Negative 15 plus 15 is 0. And so I get 0 over 0, aka I'm not happy. Okay, so you could do this in two ways. You can either factor the top and factor the bottom, or you can apply L'Hopital's rule. Well, I'm going to do the factor way just so you guys get practice. So x minus 5, there's nothing really I can do about that. I mean, I suppose I'm going to multiply it by 1. Just leave it out like that. And what two numbers multiply to positive 15 and add to negative 8? X minus 3, x minus 5. And there's your problem. There's the reason why I can't plug in x equals 5. The x minus 5 on the top over the x minus 5 on the bottom, that creates the 0 over 0. That'll be $400. So now I look at this like, okay, can I legally plug in x equals 5 now? So I've got 1 over x minus 3. Yes, I can plug in x approaching 5. So let me plug in 8. Sorry, I got a little ahead of myself. I saw that coming a mile away. So 5 goes on the bottom, minus 3, and that's 1 right there. So therefore, the limit as x approaches 5 for x minus 5 over x squared minus 8x plus 15 is 1/2. How are these two problems different? Well, direct substitution did not work right off the bat. I'm not happy. But if I factor and I cancel out the cause of the 0 over 0, I can confirm that as x gets closer and closer to 5, y gets closer and closer to 1/2. But that point, I'm shaking my finger at it, that point x equals 5 is discontinuous. You could have also done L'Hopital's rule. Let me cover this up right here. The derivative of the top would be 1. The derivative of the bottom would have been 2x minus 8. And then you would get 1 over 2 times 5 minus 8, which would be 2 times 5 is 10, minus 8 is 2. So you still would have gotten 1/2 had you done L'Hopital's rule. Okay, this one's a little bit tricky because if I use direct substitution, I always like to use my thought bubble right here. So if I plug in 8 minus 8, I get 5 over 0. Okay? Now, if we look at our tips, this falls into the non-zero over 0. So that's going to create a vertical asymptote. So a vertical asymptote is this imaginary vertical line that the function cannot actually be defined at. In fact, one side goes to infinity or negative infinity, and vice versa for the other side. One side will go to infinity, the other side will go to negative infinity, or both will go to infinity, or both will go to negative infinity. So we're trying to figure out what this case is. Big hint, there's no exponent on here, so that's very telling. And if you get a lot of practice with that, you'll see it. So what we do for this is we take the left-hand limit and the right-hand limit. And we compare both sides. So let me start with the left-hand limit first. So I'm going to plug in the left-hand limit as x approaches 8. So I'm even though I'm plugging in 8, think 7.9999999. So I'm going to apply direct substitution, and this is the legit calculus notation. So if we've got 8 from the left side, let's think critically about this. Well, the top is going to be 5, no problem. But then the bottom is 7.9999999 minus 8. Is 7.9999999 minus 8 going to be barely positive or barely negative? Barely negative. It'd be like negative 0.00001. So if we've got positive on top and 0 on the bottom, if we've got a non-zero over 0, that's going to be some sort of infinity. But since we've got a positive on top over barely negative, it's still a positive divided by a negative kind of problem. So that is negative infinity. So the limit as x approaches 8 from the left side, y wants to go to negative infinity. Now, if we look at the right side, let's take the right-hand limit. So now I'm going to plug in 5 over the right side of 8 minus 8. Now, what do I mean by the right side of 8? I mean just barely a little bit bigger than 8. So think 8.001. So if I plug in 8.001 minus 8, is that going to be barely positive or barely negative? That's going to be, so I got a 5 on the top, that's going to be barely positive. So remember, I've got 5 over 0, so that is some sort of infinity. But since this is a positive number on top and a positive number on the bottom, then the limit as x approaches 8 from the right side is positive infinity. You don't have to put a positive sign. If that makes you feel better, go for it. I'm not going to penalize you for putting positive infinity, even though calculus people would be like, well, if there's no sign, it's automatically positive. Whatever works for your brain. I am here to help whatever, I'm here to help however your strategy is, as long as it results in the appropriate solution. So if the left side of, as we approach x equals 8 from the left side, it wants to go to negative infinity. As we approach x equals 8 from the right side, it wants to go to positive infinity. So since the left-hand limit and the right-hand limit don't agree, that means that the limit does not exist. And that is the answer. Let's take a look at problem number 4. So what do we do here? Okay, so if we plug in 7 over negative 6 plus 6 quantity squared, that's going to be 7 over 0 squared, which is still 7 over 0. What does that mean? That means we have a vertical asymptote. So danger, 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 that square is going to come in handy. Okay, so if I have a square, that means that, I'll spoil it for you, it's going to be a positive regardless of whether whether you have barely negative or barely positive. And I'm going to show why. So if I take the left-hand limit and the right-hand limit, we're at negative 6 for 7 over x plus 6 quantity squared. Let me apply this over here as well. So if I apply the left-hand limit first, remember that we are applying to the left of negative 6. So even though we're in the negative world, think about it. What is a number that's barely less than negative 6? Think negative 6.001. So if we plug in the left-hand side of negative 6, negative 6.001 plus 6 is going to be negative 0.001. So I'm going to say that this is the left side of 0, but remember that's getting squared. So if I have 7 on top, and let's just say I got negative 0.001 and it's getting quantity squared, what does that mean? It means that it's still so close to 0, it's practically 0, but because that negative part got squared, this becomes 7 over the right side of 0. And if we look over here, oh sorry, we didn't finish it. 7 over 0 means it's some sort of infinity. Positive divided by positive is positive, so therefore the left-hand limit as x approaches negative 6 is positive infinity. And let's do this for the right-hand limit. So what is a number that's barely bigger than negative 6? Try something like negative 5.99999. So if we plug in negative 5.99999, we're going to see the right side of negative 6, so negative 5.99999 plus 6, is that going to be barely positive or barely negative? Negative 5.99999 plus 6 is going to be barely positive, like positive 0.0001. So I'm going to put barely positive right here. And because I get, sorry, I'm running out of space. I'm going to write this, right? Positive getting squared is obviously positive, so this is still 7 over 0 from the right side. Remember that 7 divided by 0 is some sort of infinity, and positive divided by positive is also positive. So the left-hand limit and the right-hand limit both go to positive infinity. Therefore, the limit as x approaches negative 6 of 7 over x plus 6 quantity squared is positive infinity, because the left and the right both go to the sky. Okay? All right, I'm going to close with this problem strictly because there's an x here. I'm going to close with this just because. Okay, so I'm going to plug in negative 7 in here just for the sake of time. I'm going to do this mentally. Negative 7 quantity squared is 49. 4 times negative 7 is negative 28, so 49 minus 28, that'd be positive 21. 21 minus 21 is 0. Uh-oh, that's not good. But then I get 2 times negative 7 over here. Okay, well, I'm not happy. So if I plug in x equals negative 7, I get negative 14 over 0. So if I put this in my thought bubble over here, I get negative 14 over 0. So that's going to create a vertical asymptote. But I'm kind of scared of this part. So if at all possible, I'm going to try to factor. So I've got a 2x on the top, two numbers that multiply to negative 21 and add to 4. One positive, one negative, so that is going to be x plus 7, x minus 3. So not only do I have to deal with the fact that x plus 7 is creating the 0 in the denominator, I can't cancel anything on the top. So I got to take the left and the right hand limit. So I'm going to leave some space. Let's say I put the limit as x approaches negative 7 from the left side here. Let me just get this all set up so it doesn't hurt in the end. Okay, so I'm going to plug in the left-hand limit. So think something barely less than negative 7, like negative 7.001. So if I plug in the left-hand part of negative 7, right, some of these are going to be irrelevant. So let's treat those parts like negative 7. So sorry about that. So the top part is 2 times negative 7 from the left side over negative 7 from the left side plus 7 times negative 7 from the left side minus 3. So because it doesn't go to some sort of 0, I'm going to treat this like 2 times negative 7. So that's going to be negative 14 on the top. Negative 7.001 plus 7 is going to be barely negative, so I'm going to call this 0 from the left side. And then negative 7 minus 3, well, that's not going to be some sort of 0, so I'm going to treat this like negative 10. Okay, so let's analyze this. So I've got a negative on top, and I've got a negative times a negative on the bottom, okay? Well, 0 times 10 is 0. But because there's a negative and a negative here, I'm going to make that a positive. And what's negative 14 over 0 from the right side? Some sort of infinity, but negative divided by positive is negative. So the left-hand limit wants to go to negative 14. The left-hand limit wants to go to negative infinity. Whereas over here, we're plugging in the right-hand limit. So think negative 6.9999999. And now, for the ones that create 0, pay attention to the barely positive or barely negative part. But if you have stuff that doesn't go to 0, just treat it like you would x equals negative 7. So that's going to be negative 14 on the top. I'll come back to you later. Negative 7 minus 3 is negative 10. And because we've got barely bigger than negative 7 plus 7, so negative 6.999999 plus 7 would be barely positive. So now that we've got a positive times a negative, okay, well, 0 times 10 is 0, but because there's a positive times a negative, that's going to create a negative for me. And negative 14 divided by barely negative is going to be positive. So that is positive infinity. So if the left-hand limit wants to go to negative infinity and the right-hand limit wants to go to positive infinity, what this tells me is that the limit as x approaches negative 7 of 2x over x squared plus 4x minus 21 does not exist. Okay, have a great day.